Okay, so we've been asked to, we've been given a cylindrical specimen of a nickel alloy. So imagine a regular tensile test specimen. We know that nickel has an elastic modulus of 207 gigapascals. We have measured the original diameter of the specimen at 10.2 millimeters. The load is 8,900 newtons, and we know that's going to be below the elastic limit. We've been told all of that. We've been asked to compute the maximum length of the specimen before deformation if the maximum allowable elastic deformation is going to be limited to 0.25 millimeters. So we have to go through and look at what we know. So we know that the strain is equal to the change in length over the original length. So we know this. That's going to be our maximum allowable deformation, delta L. So we want, out of that equation, L naught. That's what we've been asked for, the maximum length of the specimen. We want that L naught that's going to be associated with that. We also know that the elastic modulus, which we've been given, is the stress over the strain in the elastic region, which is the applied load, which we've been given, divided by the original cross-sectional area, divided by the strain. So we know the load, we know the original area, and we know E. We know delta L, and we can use all of this information to find the original length L naught. So rearranging this, and I always do this just by manipulating these equations, we're going to say that the strain is equal to the force divided by A naught divided by E. And so then this is equal to delta L over L naught. Remember, we're looking for L naught, so L naught is equal to delta L over this F over A naught divided by E. We know all of those things, so now I'm just going to plug them in and make sure that the units work out. So delta L is 0.25 times 10 to the minus 3 meters. F is 8,900 newtons. A naught is pi over 4 times 10.2 times 10 to the minus 3 meters squared. That's my A naught. And E is 207 times 10 to the 9th newtons per meter squared. So, checking the units, I've got newtons over newtons, which is 1. I've got meters squared over meters squared, which is 1. I end up with meters, which is what I need. Cranking through all the numbers carefully, I get that this is equal to 0.475 meters or 47.5 centimeters.